Hello everyone, welcome back to the course on Instrumentation and Process Control. Myself, Niti Mehta, Assistant Professor at Chemical Engineering Department, LJIET Institute of Engineering and Technology. So, let's just start with our today's session. As you all know that we are dealing with control system, and in this particular topic, in our previous few sessions, we have covered what do we mean by control loop, what are different elements of control loop, and how to deal with block diagram. Correct? We have seen 5 rules till now for block diagram reduction. Today we will continue with the same topic of block diagram reduction. If you remember, we have also covered what do we mean by positive feedback system and what do we mean by a negative feedback system. And we have started with the rule of block diagram reduction, and in that particular topic only we will continue today with rule number 6. Till now we have covered up to rule number 5 for block diagram reduction. Today we will start with rule number 6 for block diagram reduction. Now, one thing must come in our mind, that why we are dealing with so much rules for block diagram reduction. Correct? So, whenever there is a system, all the elements of system are represented in the form of blocks in the block diagram. Correct? Now, whenever we want to relate our input and our output in that particular block diagram, there are numerous parameters which can be affected and they are interconnected to each other. Now, suppose there is a change in input. So, definitely there will be a change in our output, but change in input of any one block can also change the entire overall transfer function of our given system. Correct? So, for this purpose only we are trying to determine overall block diagram or overall transfer function of our given system. And for that we need to reduce our entire system in a single block. Right? So, the entire loops, different loops which are present in our system need to be eliminated one by one, and we need to convert the entire complex form of block diagram in the simpler most form. And for that only we are dealing with this kind of rules, because these rules will help us to guide which kind of elimination method we need to adopt and in where we need to adopt them. Right? So, let's just start with our today's topic, which is rule number 6 for block diagram reduction technique. Rule number 6 is associated with summing point. Right? So, whenever we are talking about summing point, it refers to a point where either 1, 2 or maybe more than 2 signals are emerging and some signals are coming out of that. So, a summing point is basically a point where different type of signals are either emerging there or are coming out of that particular point. So, here we will deal with how we can shift our summing point. So, suppose this is our given block diagram. Right? So, suppose this is how summing point is given, where R of S, that is our set point, is going there. Our x value is also going there. So, both the values are having plus sign. So, it will be plus or added. And the output is coming from this particular side. So, this is basically a summation of R and X. Right. So, this value which is going into the block G is a summation value of R and X. Correct. So now if I want to shift this summing point, how I can achieve that? So this is basically a method where we can shift a summing point after the given block. So if you can see, R of S is now directly going into the block G here, and output from block G is sent into the summing point. So the summing point is basically entering in this particular point. So what we have done to shift it, we are going to give input of both the individual values individually to block G, and resulted will be added up in the summing point. Right. So if you can see here, R is going to G, X is also going to G, and the resultant of both of them is them sum up in the summing point, and then you will be getting the same result as the output. So if you write transfer function for the system, it can be given as CS. CS is dependent on G into RS plus X, because R plus X is the output here. So G into RS plus X. Right. So it can be written as, if you multiply G individually, then it will be G RS plus G of X. Same way, if you want to write overall transfer function for this particular point, you can write it as CS equals to G R of S plus X into G, which is again equals to G RS plus X G. Right. So this is how we can shift a summing point from one position to another position. So we can shift it either from initial condition to the furthermost condition. Right. Now, the next point is point number 7, which is shift a takeoff point before a block. Now, what do we mean by takeoff point? Let's see here. Takeoff point refers to a point where the outlet value is being distributed in two different ways. Right. So we are just distributing the outlet values here. Correct. So if you can see in this particular point over here, in this way here, if you can see here, what is happening over here is the outlet of G is distributed in two ways. First one is C of S and the next one is X. Correct. So here we want to shift this take off point from one point to another. Then let's see how we can do this in this particular way. So you can see that whatever the value of R is going there, we just need to send it to the transfer function which is equivalent to G. So it is G here, and then you can get X as output. Right. So I have shifted this takeoff point from after the transfer function to before the transfer function here. Here it is after the transfer function, and in this particular case I have shifted it from after to before condition. Right. Now if you see how we need to write the overall transfer function. So the overall transfer function can be written in the same way as C of S equals to G into R of S, because C, which is output, is equivalent to transfer function into input. Correct? And we can directly write it in this particular way. And for this particular block also, if we want to write transfer function, it can easily be written as CS equals to G into R of S, and similarly XS equals to G into R of S. Right. So this is about point which is known as take off point. Right. How to deal with take off point. Now let's deal with next rule, which is shift a takeoff point after the block. If I want to shift this after after the block. Initially in rule number 7 we have shifted it before the block. Now we will shift it after the block, right? So if I want to shift this particular point from here to this way or this side, so what we need to do is, just see, you just need to add 1 by g, right? Whatever transfer function is there, you just need to take inverse of your block transfer function and then you can get the desired results. So here Cs is given by G into R of S, right? And X of S is equivalent to R of S. So in this way, here also if you can write Cs is equals to G into R of S and X is equals to Cs into 1 by G. Correct. So these are the basically rules for determining a transfer function. Now as you can see here, we need to deal with decision making. Decision regarding which rule should be selected to solve a given block diagram or to reduce a block diagram, right? So for that we are having this method, right? What we have done here is we have made our preferences. Preferences refers to we have made our choices. What should be our first choice, and if they are not fulfilled, then what should be our second choice, right? So if you can see in this particular table over here, first choice of selection amongst the rule is rule number 1, 2 and 3, and for the second choice we have kept rule number 4, 5, 6, 7 and 8, right? So first preference or first choice should be our first 3 rules, and even among those first 3 rules we must ensure that we should go in sequence of rule number 1, rule number 2 and then only rule number 3. It means that we first need to see if there are any series of block or cascades, right? So if there are any series of blocks or cascades, then we must select them at priority list. Then if it is not there, then we should go for block in parallel, and if even parallel blocks are not there, then only we can be going for the blocks in the loop, right? So this 3 will be our first preference. After this, our next preference should be rule number 4, rule number 5, 6, 7 and 8, which are adjustment of summing point or shifting point from before and after the block or shifting of takeoff point. So this is all about block diagram reduction. Hope all the things are clear. Thank you.